Good morning, everyone, and welcome to today's lecture. This is lecture number 4, and we are dealing with collisions in this lecture, and most likely we will be able to finish this chapter, this part today itself. In the previous class, if you remember, we had seen the three types of collision. We had finished the three types of collision. One was a perfectly elastic collision. Then there was a perfectly inelastic collision, and the third one was somewhere in between that perfectly elastic and perfectly inelastic. We call it inelastic collision. The value of E for perfectly elastic collision is 1. Perfectly inelastic, where they move together after colliding, is 0. Value of E is 0. And for an inelastic collision, it lies somewhere between 0 and 1. Do we remember it? Yes or no? Then we had seen how can we solve problems of a perfectly elastic collision. And we had seen that we need to apply any one or any two of these equations. Which equations am I talking about? Equation number 1, m1u1 plus m2u2 is equal to m1v1 plus m2v2. Do we remember this equation? Law of conservation of momentum. Then you have to apply E is equal to 1. That means V2 minus V1 is equal to U2, U1 minus U2. With these two equations, you should be able to solve any problem that comes in your way. We had seen special case. What is the special case that we had seen? We had seen a special case if you have a perfectly elastic collision between two bodies, if their masses are same, and it is a perfectly elastic collision, then what happens? Can anyone remind me what happens when there is a perfectly elastic collision of two bodies which are having equal masses? Can anyone tell me what happens there? Do you remember it? Yes? Perfectly elastic collision of two bodies of equal masses. What happens then? Anyone remembers? Perfectly elastic collision of two bodies of same masses. Anyone remembers? What happens then? Perfectly elastic collision of two bodies of same masses. What happens then? I'll give you 5 minutes. Read it and let me know. And I think we had done a question also on this. Whenever two bodies of equal masses, when they are colliding with each other and the collision is elastic, they interchange their velocities. We had done a question also here where we had two blocks of same masses, 10 kg, one moving with 50 meter per second, the other moving with 20 meter per second. After their collision, they had interchanged their velocities. The piche wala one, the one which was back, now moves with the velocity of the front one, and the front one moves with the velocity of the backward one. This is the most important thing that you have to remember in this chapter. And I hope that you will remember it. Now comes this question. You have an perfectly elastic collision between these two bodies. These are the two bodies, and the collision is perfectly elastic. This is question number 1. Perfectly elastic collision means the value of E is 1 for this question. Let me call this body as body A, and let me call this body as body B. Now I ask you, if this is a perfectly elastic collision between two bodies, what will be the velocities of body A and body B after collision? What will be the velocity of A and velocity of B after collision? It's a perfectly elastic collision. What is the answer for this one? Yes.
Equals to 3, V2 equals to 4. V equals to 3, V2 equals to 4.
So what is the answer for this one? What will be their velocities after collision? What will be the velocity of A and what will be the velocity of B? Anyone with an answer?
V1 equals to 3.
Yes? Tell me.
V1 equals to 3.
V1, oh, there is no one, there is A and B. Names are A and B. What will be the velocity of body A?
3 meter per second.
In which direction? Forward or backward?
Forward.
This is forward, this is backward.
Forward or backward? Backward.
So it will be like this. The body A will return back with the velocity of body B. Body B will go back with the velocity of body A. That is what that happens when we have perfectly elastic collision of two bodies of the same mass. They will interchange their velocities. Do we understand this?
Yes, sir.
Okay?
Yes, sir.
Okay. Then comes this question. It is again the case of a perfectly elastic collision. What will be the velocities of the two bodies after collision? This is body number 1 and this is body number 2. What will be the velocities of body number 1 and body number 2 after collision? Can I have the answer for this one, beta?
టూ అవుతుంది. ఫస్ట్ బాడీ మాస్ ఇస్ 0. సెకండ్ బాడీ మాస్ ఇస్ 2 మీటర్ per second.
Yes, do we get an answer here?
V2 equals to 2 meter per second.
V2 is equal to
2 meter per second.
which direction?
Backward. Front.
So it looks like this. After collision, body number 1 comes to rest. After collision, body number 2 moves with the same velocity as body number 1 in the same direction also. Body number 2 has taken the velocity of body number 1, and body number 1 has taken the velocity of body number 2. I hope we understand this. Yes or no?
Yes, sir.
Great. Comes another question, my dear friends. This is question number 3 coming for you. Two identical balls are approaching each other on a straight line with velocity 2 meter per second and 4 meter per second respectively. Find the final velocities after elastic collision between them. So there has been an elastic collision between them. Yes, my dear friends. Do I have anything that looks like an answer here? Yes or no? No, yes.
V1 4, V2 2.
Okay, I have an answer. And what is the answer? Yes, I have an answer here, and I hope that is the correct answer. Tell me, what is the answer?
Equals to 4 meter per second. V2 equals to 2 meter per second.
So they will interchange their velocities. As you can see, this gentleman after collision will move here. This gentleman after collision will move here. This gentleman will move with a velocity of the other one, 2 meter per second. This gentleman will move here with a velocity of 4 meter per second. So basically what has happened is that they have interchanged their velocities. Yes or no? No, yes. Okay, great. I hope you are able to understand the question. Now let me give you this one. The next question. Three balls A, B, and C of same mass M are placed on a frictionless horizontal plane in a straight line as shown. Ball A is moved with velocity u towards the middle ball B. All the collisions are elastic. Find the final velocities of the ball. I'll give you 2 minutes to solve this. Yes, do we have any answer? Do we have an answer here, beta? No answer. Okay. So this ball A will hit ball B. So the velocity of A will become 0 and the velocity of B will become same as the velocity of A, u. Then this ball will hit ball C. So this is at rest. So this ball C will be moving with a velocity u finally, and this ball will come at rest. So basically ball A and ball B will come to rest and ball C would be moving with a velocity of u after the collision. Do we understand this? Okay. We understand this? It's just interchanging their velocities and nothing else. One which is moving stops, one which is stops, one which is stopped starts to move. This is the last one in this category, and I hope you can tell me the answer fast. There are four balls which are placed on a frictionless surface. A and D are moved with the same speed u towards the middle ones. Assuming elastic collision, what are the final velocities? Yes, my dear friends, do we have an answer for this one?
Zero,
Yes.
sir. B equals to 0, sir.
What are the velocities of all the balls? All the ball will come to rest.
No, sir.
A, B, C, and D. All the balls you need to tell me the answer. All the balls.
A equals to 0.
Final velocities we are talking about, beta. Okay. So I guess there is a doubt. So what will happen? After first collision, B and C will be moving towards each other with the velocities of A and D. When A and D collide with B and C, A and D will come at rest and B and C will be moving towards each other. Then what will happen? Then B and C will collide and they will interchange their velocity. So now B will be moving here and C will be moving there. Then in the last step, what will happen? B and C, which are moving, will collide with A and D. So finally, what you have, your D will be moving here, your A will be moving back, and B and C would remain at rest. Is it difficult for you to understand this? Okay, that's it. That is what you need to understand in these types of questions. Have you noted it down, beta?
Completed, sir.
Then you can do a second case. In the second case, what is going to happen, that it is an elastic collision. So E is equal to 1. A small body is colliding with a very big body. A small body is colliding with a very big body. Now, if a small body collides with a very big body, nothing happens to the very big body. The very big body is at rest. Let us say very big body can be a wall, it can be a truck, a ball hitting a truck. Nothing happens to the truck. So this could be a wall or this could be a truck. A ball hitting a truck, nothing will happen to the truck. The truck will keep on moving with its velocity. If the truck is at rest, truck will not go anywhere. In that case, what happens? The ball which is hitting the stationary big vehicle will just come back with the same velocity but in the opposite direction. So what do you see here? In the green one is the velocity with which the ball is hitting. What you see in the pink one is the velocity with which it is coming back. Do we understand this? Yes or no? We understand this? Have you noted it down, bacha? Okay, can you move on to the next thing? We move on to the next thing, and that is a perfectly inelastic collision. Perfectly inelastic collision. Remember, in a perfectly inelastic collision, the value of E is 0. The value of E is 0. The value of E is 0. We all remember this? The value of E is 0 in a perfectly inelastic collision. Yes or no?
Sir.
Okay, so again we have the same diagram. M1 moving with velocity U1, M2 moving with velocity U2. After collision, M1 moving with velocity V1, M2 moving with velocity V2. But remember, it's a perfectly elastic. Let me Do not draw this diagram. You might get confused. Do not draw this diagram. I will give you another diagram. So what happens? In most of the cases, the diagram that you will have will be something like this. This would be, let us say, M1, or let me call this as M2, a block, M2 moving with a velocity U2, and there would be something which will be striking it, M1 moving with a velocity of U1. It will be a bullet, something of that nature. And then this will be the condition before collision, and after collision I will draw in blue. So after collision, this would be sitting inside it, this would be your M2, and this would be your M1, and this would be moving together with a velocity v. This is a better diagram. Do we understand what has happened here? Yes or no? You understand what has happened here? Okay. So now the first thing that you will apply will be the law of conservation of momentum, my dear friends. So what will be the law of conservation of momentum here? Initial momentum is m1 u1 plus m2 u2, and the final momentum will be m1 plus m2 multiplied by v. We can easily calculate v from here. Yes or no? Then the second thing that they might ask in this question is, what is the initial kinetic energy? So you can find out the initial kinetic energy. Initial kinetic energy is half m1 u1 square plus m2 u2 square. They can also ask the final kinetic energy. Final kinetic energy will be half m1 plus m2 into v square. Can you tell me which kinetic energy will be more? Initial kinetic energy will be more or final kinetic energy will be more? Yes, bacha. Which kinetic energy will be more? Initial kinetic energy or final kinetic energy?
Kinetic energy, sir.
Which one?
Final.
Initial kinetic energy would be more because energy is lost. I have already told you that. You don't seem to remember it. I hope you will remember it now. So the initial kinetic energy in this case would be greater than the final kinetic energy. Final kinetic energy in no case can be more than the initial kinetic energy. It can only be equal, and it is equal only in the case of elastic collisions. So initial kinetic energy is always going to be less than the final kinetic energy, and then you can find out the difference in kinetic energies. So they can also find out, they can also ask you what is the loss in kinetic energy. That is the next question that they can ask you, bacha. Loss in kinetic energy. So loss in kinetic energy will be initial kinetic energy minus final kinetic energy. You can find out the initial kinetic energy, you can find out the final kinetic energy and then subtract it. Or if you don't want to do it, there is a shortcut formula, and that is the formula I am going to give you. The loss in the kinetic energy will be m1 m2 upon m1 plus m2 into u1 minus u2 whole square divided by 2. If you can remember this formula, you can put this formula and get your answers quickly. I will give you 2 minutes to note down this formula. Please note it down. Then we will move on and try to solve a question, and I hope that you are able to solve this. So this is a question coming for you. So there is a block which is at rest. The mass of this block is m. A small bullet, a bullet of mass m, a bullet of mass m strikes a block of mass also m and gets embedded in it. Find the velocity of the block and the loss in kinetic energy. Do we understand this question, dear? You have a block which is at rest, a bullet moving with a velocity u strikes the block and it gets inside the block. The two will now move together. This is a case of perfectly inelastic collision. The two will now move together. Can you now tell me the velocity of the block and the loss in kinetic energy? I will give you 2 minutes to do this. Can you do this on your own? Yes, well done. Right. So how are you supposed to do this? As you can see, after collision, they will move like this. Both of them will move together. Block and the bullet. They will move together with the velocity v. The only thing you have to do here is to apply the law of conservation of momentum. Initial momentum. What is the initial momentum? If you look at the initial momentum, we have the ping momentum of this bullet. What is the momentum of this bullet? Can you tell me? What is the momentum of this bullet? Can you tell me what is the momentum of this bullet, beta? Okay, no one can tell me. Momentum of this bullet is m into u. So I write m into u. Initial momentum of this bullet is m into u. Can you now tell me the momentum of this block? The block is at rest. No one knows it. Okay, not a problem. The momentum of this block, the block is at rest, is 0. So plus 0. That should be equal to, my dear friends, the final momentum. The final momentum is the momentum of this entire thing. This bullet is inside this mass and they are moving with a velocity v. Can anyone tell me? Can anyone tell me the momentum of this block and the bullet together? Both the block is moving, the bullet is inside the block, and they are moving with a velocity v. Anyone?
0.
It is moving with a velocity v. How it can be 0? The mass have got added up, m1 plus m2, m and m. It becomes 2m. 2m multiplied by v. So my m and m will get cancelled. and my velocity will become u by 2. That was the answer that we were looking at. The velocity of the block together with the bullet is u by 2. The velocity of the block together with the bullet is u by 2. Let me now move on to the initial kinetic energy. Initial kinetic energy is half into m into u square. Only one body is moving. The final kinetic energy, half. Both the blocks are moving together. The block is moving with the bullet. The mass is m plus m 2m into v square. Now the value of v, we have actually calculated. V is coming as u by 2. So I write it as half into 2m into u by 2 ka square is u square by 4, my dear friends. 1 half cancels. You have to find the loss in kinetic energy. Loss in kinetic energy is equal to initial kinetic energy minus final kinetic energy. Initial minus final. You can see initial is half mu square minus final is 1 by 4 mu square, my dear friends. Now you can take the LCM. 4, 2 minus 1. So that becomes equal to 1 by 4. I hope you understand how I got this. 1 by 4 mu square. That is the loss in kinetic energy. Do we understand this? How I have done this? Do we understand how I have done this? Boys and girls, do we understand this? I don't see everyone. Okay. So do it fast. Have you noted it down? Then I can give you one more question. Okay then. So do it fast one. We can complete one more question here, and that would be good enough for your exams. Question number 2. I have a block of 2 kg. Remember 2 kg is the mass. It is at rest here. And I have a bullet of mass 1 kg moving with a velocity of 6 meters per second. I have a bullet of mass 1 kg moving with a velocity of 6 meters per second, and there is a block which is at rest, 2 kg block at rest. This bullet is going to get inside this block and it will remain embedded. You have to tell me what is the final velocity of this block with the bullet inside it. 2 kg block with the bullet inside it will move with a velocity v. You just have to tell me what is the final velocity of this bullet and the block system, because now they are moving together, my dear friends. I hope that you can understand what I'm asking and you can tell me the answer of this one. What is the answer, my dear friends? We have anything like any answer here? It's a simple question. And I know you can do this. Yes, anyone with an answer? It's a simple question, beta.
3 meter per second, sir. 3, sir.
Hmm, 3 is not correct. The bullet is also there inside the block, beta. So, the initial momentum of the system is 1 multiplied by 6 coming from here. This green block is at rest. So its momentum is 0. Do we understand up till here?
Yes, sir.
But what is the final momentum, beta? In this final momentum, this blue thing, what is the mass of this blue thing? It has the block as well as the bullet. What is the mass of this thing, beta? Tell me. 1 kg is the mass of the bullet plus 2 kg is the mass of the block. M1 plus M2. M1 is 1, M2 is 2 into V. So 6 is equal to 3V. So your V becomes not 3 but 2 meter per second, my dear friends. Do we understand how I got this?
Yes, sir.
See, I've always just applied this formula. M1 U1 plus M2 U2. Same formula I'm applying. The only thing is here is the velocity of the second block is given as 0. Do we understand this? Well done. This brings us to an end of this class, and we are done with the concept of collision. In the next class, we will move ahead and venture into the next topic. I hope everyone has understood what we have discussed here.
Yes, sir.
Okay, take care, and we'll see you in the next class. Bye bye.
Thank you, sir.
Bye, beta. Everyone has understood this?
Yes, sir.